Today we're going to be solving a fairly standard projectile problem. A cannon fires a cannonball at 30 meters per second at an angle of 25 degrees above horizontal. We want to know how far the cannonball goes if it lands at the same height that it started from. My initial velocity is 30 meters per second, and I know it goes at 25 degrees above horizontal. So I'm going to draw my initial velocity and the angle 25 degrees. 30 meters per second at a 25 degree angle. First thing I do with this initial velocity, I get rid of the angle part. I want to treat horizontal and vertical as two separate entities. So I want to know how fast the cannonball is going horizontally and how fast the cannonball goes vertically. My horizontal velocity and my initial vertical velocity. These two are perpendicular, which means this is a right triangle. I'm going to use SOHCAHTOA to find out how fast it's going horizontally and how fast it goes vertically. For this angle, the 25 degree angle, Vx is my adjacent side. Adjacent means next to, and this is next to the 25 degree angle. Byi is the opposite side because it's on the opposite side of the triangle from the angle. And my diagonal Vi is the hypotenuse. If I want to find Vx, the adjacent side, and I know the hypotenuse, I need to use cosine, ca. CAH means cosine for C equals adjacent A over the hypotenuse H. Or in the case of this triangle, cosine of 25 degrees, that's my angle, 25 degrees, equals my adjacent side, which is Vx, over my hypotenuse, which is Vi, 30 meters per second. To solve this equation, I need to multiply both sides by 30, which is going to cancel it out on the left. And on the right, it's going to cancel it out on the right. On the left, I've got 30 cosine 25. So Vx equals 30 cosine 25. Do a quick math here. 30 times cosine of 25. And I get a horizontal velocity of 27.2 meters per second. I can find Vyi the same way, except because this is my opposite side, I need to use the SO part. So sine equals opposite and hypotenuse. So for this triangle, sine of 25 equals my opposite side, Vyi over the hypotenuse, Vi 30. Again, multiply both sides by 30, and you get Vyi equals 30 times the sine of 25 12.7 meters per second. Okay. I've broken up my initial velocity into the horizontal and vertical components. Now, let's see what we're really looking for here. Wants to know how far the cannonball goes. Let's draw a picture. I find that drawing a picture always helps me understand exactly what's going on. It's going to end up at the same height it starts out. I know that my initial horizontal velocity is 27.2 meters per second. My initial vertical velocity is 12.7 meters per second. But there's other stuff I know also. I should know the acceleration for the vertical direction. That's just from the gravity of the Earth. So my acceleration is negative 9.81 meters per second squared. The other thing I know that's not completely clear, but it gives us a hint here. It says the cannonball lands at the same height it was launched from. If something goes up and then comes back down to the same height, your vertical displacement is 0. Because the initial height, yi, is at the same level as the final height, then the vertical displacement is 0. The horizontal displacement is definitely not 0. In fact, that's what we're trying to find, delta x. But the vertical displacement, delta y, is 0. Vyi was 12.7 meters per second. I'm going to use these three variables to find eventually delta x. I'm looking for delta x. This is a horizontal variable, and I only have one horizontal equation. Delta x equals Vx times delta t. I know Vx from the first part when I broke up Vi into components. It's 24.6 meters per second. I need to find the time in order to solve for delta x. I could use these three variables to find the time using this equation. Delta y equals Vyi delta t plus 1/2 a delta t squared. The other day we tried a problem where this ended up with a quadratic equation. That will not be the case here because my delta y is 0. Delta y is 0, so 0 equals Vyi 12.7 times delta t plus 1/2 times my acceleration, negative 9.81 delta t squared. All right, 1/2 times negative 9.81 is negative 4.905. So I get 0 equals 12.7 delta t minus 4.905 delta t squared. I need to solve for delta t, which means I need to get delta t all by itself. I'm going to subtract 12.7 delta t, this entire expression, from both sides. On the right-hand side, it cancels. 12.7 delta t minus 12.7 delta t is 0. So I end up with negative 12.7 delta t equals negative 4.905 delta t squared. Now I've got delta t on both sides here, which you might think is a bad idea, but this one is squared. So what I can do is divide by delta t on both sides. Perfectly legal to do this. On this side, delta t cancels out. On this side, delta t cancels the square part of delta t squared, leaving 1 delta t times negative 4.905. I'm going to rewrite this over here. Negative 12.7 equals negative 4.905 delta t. Now I just divide both sides by negative 4.905. Cancels out over here. Over here. I get 2.59 seconds. Now I know my time. I know my horizontal velocity. I can use those to find my horizontal displacement. .6 meters per second times my time, 2.59 seconds. .7 meters. That's my final answer.